On question number 20, we are given this curve here, y equals x root ln x, and we are told that the equation of the tangent to this curve at the point where x is equal to a is given by this equation here. Now, I've made a plot here, but this is not what the actual curve looks like, so you can consider this to be just a rough sketch. The curve looks nothing like what I've drawn here, right? But it can be just some random sketch. What we are told here is that the tangent is at the point where x is equal to a. So the point where I have marked the tangent, so this x coordinate here is equal to a. The y coordinate is way over somewhere here. The y axis is way over somewhere here, but that doesn't really matter to us. Now we are given that the equation of this curve, the equation of the straight line is this. Now what I'll do here is I'll rewrite that as y is equal to, I'll divide the whole thing by 4 and say b over 4x and then minus a over 4. Now if the x coordinate is equal to a, we can think about what might be the y coordinate at this point. And given that this point lies on the straight line as well as on the curve, there are two different ways we could define the y coordinate. Now using the curve, if x is equal to a, we could say the y coordinate is equal to a root ln a, right? So that's just substituting x equals a into this one. So this coordinate here, we have that when x equals a, y is equal to a square root of ln a. Now that was using the equation of the curve that we get y is equal to this coordinate, but that's not the only way to get that y coordinate. We could also use the equation of the line and substitute x equals a into this. Now when we substitute x equals a, we're going to get 4y, so we'll then divide that by 4. So if x equals a, that bit is going to be b times a. I'll write that as ab minus a. So that's equal to 4y, so I'm going to then divide that by 4. So the coordinate of that point can also be written as a comma ab minus a over 4. So these two y coordinates are equal. So if I put these two equal to each other, we can get one equation that relates a and b. So making the two y coordinates equal will give us a square root ln a is equal to, on the numerator here, I could factor out an a term. So I'll write this as a times b minus 1 over 4. So we could cancel off an a term from both sides. I'll multiply the 4 onto this side here. So I have 4 square root ln a is equal to b minus 1. And I suppose we'll make b the subject and say that this is 4 square root ln a plus 1. So what we've done is we have one equation in terms of a and b. Now on this question, we are asked to determine the exact value of a. So we are trying to solve this for a. So there must be some other way to get another equation out of this. So the way we get the second equation here is by using the fact that the line is a tangent to the curve. So if a line is tangent to the curve, at the point where x is equal to a, the gradient of the curve and the gradient of the straight line must be the same. Now the gradient of the straight line is just b over 4. Right? So what we need to work out is what would be the gradient of the curve. Now the gradient of the curve is given by just differentiating this. So to differentiate this, we're going to have to use the product rule, like u times v. So in this case, I'll actually write the terms out. So I'm going to say u is equal to x and v is equal to square root of ln x, but I'll write that as ln x to the power half. Now differentiating this will give us du over dx is equal to 1. Now dv over dx, we need to use the chain rule. So bring the power to the front, reduce the power by 1. So this will be a half times ln x to the power minus half, and times by the derivative of the inside bit. The derivative of ln x is 1 over x. Then dy over dx, so using the product rule, is going to be u times dv over dx plus v times du over dx. So when I do u times dv over dx, this x term will cancel out with this 1 over x. So to just simplify the working, I'll write this as a half times ln x to the power minus half plus v times du over dx. That's going to be ln x to the power of a half. Now I can put this back into square root form, so I think I will do that here. So I'm going to say now ln x to the, so I'll rewrite this bit first. Ln x to the power half, that's just the square root of ln x. The first bit here, to the power minus half, is the same as writing 1 over ln x to the power half, which then becomes ln square root of ln x. So this bit can be written as 1 over 2 square root ln x. So this is what dy over dx is. So what we want to know is what is the gradient of the curve at the point where x is equal to a. So let's say dy over dx at x equals a. So dy over dx at the point where x equals a will be given by 1 over 2 square root ln a plus the square root of ln a. So this gives us the gradient of the curve at this point here is given by this expression. But we also know that the gradient of the curve at this point is the same as the gradient of the tangent line. And based on the equation of the line, we know that the gradient is equal to b over 4. So we can also say at x equals a, so from the straight line, so from y equals b over 4x minus a over 4. So from the equation of the straight line, we know that the gradient at this point, so we know that the gradient is equal to b over 4. So which means these two things are also the same. So I can then say that this bit here is equal to this here. So we have 1 over 2 root ln a plus the square root of ln a is equal to b over 4. But what we showed before is, so if I just bring this term down here, so we showed that b is equal to this expression. If I just copy that down here, so we already showed that b is given by this, so I can replace b by that term. But before doing that, what I'll do is multiply all of this by 4 first. So that would give us, multiplying by 4, 4 divided by 2 will give us 2 over square root ln a plus 4 square root of ln a is equal to b. But b is the same as this, so I'll replace this bit by 4 square root of ln a plus 1. Now to solve this equation, we can cancel out these two terms because that's just subtracting 4 square root of ln a. So that means we're going to be left with 2 over square root of ln a is equal to 1. And rearranging this would give us, multiplying this onto the right hand side, would give us square root of ln a is equal to 2. So therefore ln a is equal to this squared, which is equal to 4. And then raise both sides to e to the power, so that gives us a equals e to the power of 4.